This is question number 8 from the SACE Stage 2 Physics course companion from the Cyclotron chapter. Here we have an electron which is accelerated by a cyclotron and exits a cyclotron with an energy of 7.8 times 10 to the power of 10 electron volts. The cyclotron has a magnetic field strength of 2.1 Tesla. First we need to calculate the radius of the cyclotron. This is a fairly tricky question. We're using the relationship EK equals Q squared, B squared, R squared on 2m. We're given the energy, it's in electron volts. We need to substitute it into this expression after we've rearranged it for R. Now the rearrangement can be a little bit tricky, so I'll go through that. So first we're going to multiply through by 2m. So we have 2m EK equals Q squared, B squared, R squared. Then we're going to divide through by Q squared, B squared. So we have R squared equals 2m EK all over Q squared B squared. Now we're going to square root all of that so that R equals the square root of 2m EK Q squared B squared. Now if we have the square root and the square, they kind of cancel out, so we can actually write this to make it a little bit easier as 2m EK square rooted all over QB. This saves us one extra step when we go calculating our expression for the radius. And yeah, it's just a nice little trick. So if you can see things like that, please try to use them. Alright, so now we just need to work out the energy in joules. So we're given that the energy is 7.8 times 10 to the power of 10 electron volts, which we're converting to joules, so multiplying by the charge of an electron, which if we substitute into our calculator we get 1.25 times 10 to the power of minus 8 joules. And now we can substitute all of these things from the question into our expression that we've got just above. So R will be 2 times now the mass of an electron is 9.11 times 10 to the power of minus 31 kilograms. The energy we've just calculated, 1.25 times 10 to the power of minus 8, divided by the charge of an electron, so it's 1.6 times 10 to the power of minus 19, and the magnetic field strength we're given in the question, which is 2.1, square root all of that. And if we substitute that into our calculator, we get 0.45. Let's get rid of that. It doesn't look good. That ends up being 0.45 meters, which looks a bit nicer if we just write it as 45 centimeters. So that question is fairly tricky. A lot of rearranging, a lot of conversions, and then finally the substitution. Finally, for the next part, these are much more straightforward. For part B, we need to work out the period of the motion of the electron. So it's using the relationship T equals 2 pi m on UB. 2 pi is 2 pi. Mass of an electron is 9.11 times 10 to the power of minus 31 kilograms. Charge from before, 1.6 times 10 to the power of minus 19. And the magnetic field strength is 2.1. Substituting that into our calculator, we get 1.7 times 10 to the power of minus 11 seconds. Last part, we need to work out the energy in electron volts of an alpha particle with a mass of 6.645 times 10 to the power of minus 27 kilograms and charge 3.2 times 10 to the power of minus 19 coulombs that exits the same cyclotron. So here we're just using the expression for kinetic energy, Q squared B squared R squared on 2m. Now we're given all the information in the question, so the charge is 3.2 times 10 to the power of minus 19. Magnetic field strength is the same. Radius is the same. The mass is a bit different. 6.645 times 10 to the power of minus 27. which if we substitute into our calculator, we get 6.9 times 10 to the power of minus 12 joules. And to convert that to electron volts, we need to just divide by the charge of an electron, which if we do that, we get 4.3 times 10 to the power of 7 electron volts. So that one's also a little bit tricky. There's a few different things going on. The substitution can be a little bit tricky if you're putting it into your calculator. Most people who get this wrong usually isn't from understanding, it's just through substituting into the calculator and then remembering to convert joules to electron volts by dividing by the charge of an electron. But aside from that, that wasn't too bad. Part A really was the tricky question. The rest of these were fairly straightforward.